Welcome to day 4 of Computer Basics. Today we're diving into the fascinating world of operating systems, or OS for short. Every time you power on your computer or smartphone, the very first software that springs into action is the operating system. But what exactly does it do and why is it so important? In this video we'll explore the different types of operating systems, understand their unique roles, and see how they shape our digital experiences. Let's get started by recalling what an operating system actually is. Operating system, often called OS, is the main software that manages all the hardware and software on your computer or device. Think of it as the bridge that connects your applications to the physical components of your machine. Without an OS, your computer wouldn't know how to use its memory, process data, or even display information on the screen. It's the silent manager working behind the scenes, making sure everything runs smoothly. You might already be familiar with some common operating systems. Microsoft Windows is widely used on personal computers, while macOS powers Apple's laptops and desktops. Linux is popular among developers and servers, and Android is the leading OS for smartphones. Each of these systems has its own strengths and is designed for different types of users and devices. The operating system is essential because it manages everything from running your favorite apps to handling files and connecting to the internet. It also ensures that your device's hardware, like the keyboard, mouse, and screen, work together seamlessly. Without an OS, using a computer would be nearly impossible for most people. Now that we know what an operating system does, let's look at the main types of operating systems. Each type is designed for specific tasks and environments. The four major types we'll discuss today are batch operating systems, time-sharing operating systems, distributed operating systems, and real-time operating systems. Let's break down each one. First up is the batch operating system. This type of OS was common in the early days of computing. In a batch operating system, similar tasks are grouped together into batches. These batches are then processed automatically, one after another, without any need for user interaction. This made it possible to handle large amounts of data efficiently, especially in business and scientific applications. Imagine a company that needs to process payroll for hundreds of employees. Instead of entering each employee's data one by one, all the information is collected and processed as a single batch. The batch operating system takes care of running each task in order, saving time and reducing errors. This approach was especially useful before interactive computers became common. While batch operating systems were efficient for repetitive tasks, they had some limitations. Users couldn't interact with the system while jobs were running, and if an error occurred, the entire batch might need to be reprocessed. As technology advanced, more interactive systems became necessary for modern computing needs. Next, let's talk about time-sharing operating systems. These systems allow multiple users to access a computer at the same time. The OS quickly switches between tasks, giving each user a slice of processing time. This makes it feel like everyone is using the computer simultaneously, even though the CPU is handling one task at a time. In a time-sharing operating system, the CPU divides its time among all active users and tasks. For example, in a university computer lab, several students might be logged in at once. The OS ensures that each student gets enough processing time to work smoothly, switching between users so quickly that no one notices any delay. Time-sharing operating systems made computers much more accessible. Instead of waiting for your turn, you could use the computer alongside others. This was a huge step forward for education, business, and research, allowing more people to benefit from computing power at the same time. However, time-sharing operating systems also had their challenges. If too many users were active at once, the system could slow down. Managing resources efficiently became crucial, and system administrators had to monitor usage to ensure fair access for everyone. Let's move on to distributed operating systems. These systems connect multiple computers through a network, making them work together as if they were a single system. Distributed OSs are designed to share resources, data, and tasks across different machines, improving efficiency and reliability. In a distributed operating system, computers are linked together, often over a local or wide area network. They share files, processing power, and even applications. If one computer fails, others can take over its tasks, making the system more robust and less likely to experience downtime. Distributed operating systems are used in many modern applications, such as cloud computing and large-scale web services. For example, when you use a search engine, your request might be handled by several computers working together behind the scenes. This allows for faster processing and better performance. Despite their advantages, distributed operating systems can be complex to manage. Coordinating tasks and data across multiple computers requires careful planning and advanced software. Security and data consistency are also important concerns in distributed environments. Now, let's explore real-time operating systems, or RTOS. These systems are designed to process data and respond to inputs instantly, often within milliseconds. Real-time OSs are used in environments where timing is critical, such as medical devices, robotics, and air traffic control. A real-time operating system guarantees that tasks are completed within a specific time frame. For example, in a robotic arm used in manufacturing, the OS must respond to sensor data immediately to ensure precise movements. Any delay could result in errors or even accidents. You might be surprised to learn that real-time operating systems are all around us. They power everything from medical equipment and industrial robots to traffic lights and even some video games. Whenever a system needs to react quickly and reliably, an RTOS is often behind the scenes. Designing a real-time operating system is challenging because it must guarantee responses within strict time limits. Developers need to carefully manage resources and ensure that the system can handle unexpected events without delay. This makes RTOS development a specialized field within computer science. Let's take a moment to compare the four main types of operating systems. Batch OS is great for repetitive automated tasks. Time-sharing OS allows multiple users to work together. Distributed OS connects many computers for shared power. Real-time OS ensures instant responses for critical systems. Each type serves a unique purpose in the world of computing. Choice of operating system depends on the needs of the user or organization. For example, a business processing large amounts of data might use a batch OS, while a university lab could benefit from a time-sharing OS. Distributed OSs are ideal for cloud services, and real-time OSs are essential for life-saving equipment. Today, operating systems are everywhere, from personal computers and smartphones to smart TVs and even cars. Each device uses an OS tailored to its specific needs, ensuring smooth operation and a user-friendly experience. The diversity of OS types allows technology to adapt to countless scenarios. Operating systems have evolved dramatically over the years. Early systems were simple and limited, but today's OSs are powerful, flexible, and capable of handling complex tasks. Advances in technology continue to shape how operating systems are designed and used. Security is a major concern for all types of operating systems. Modern OSs include features like user authentication, encryption, and regular updates to protect against threats. Whether it's a personal device or a large network, keeping the OS secure is essential for safe computing. The user interface is how we interact with an operating system. Some OSs use graphical interfaces with windows and icons, while others rely on command line input. The design of the interface can greatly affect how easy or difficult it is to use the system. Operating systems provide the foundation for running applications. Whether you're browsing the web, editing documents, or playing games, the OS manages resources and ensures that each app works properly. Compatibility between the OS and applications is key for a smooth experience. Mobile operating systems like Android and iOS are designed specifically for smartphones and tablets. They focus on touch interfaces, battery management, and mobile connectivity. These OSs are optimized for portability and ease of use, making them perfect for on-the-go computing. Desktop operating systems like Windows, macOS, and Linux are built for personal computers and laptops. They offer powerful features for productivity, entertainment, and customization. These OSs support a wide range of hardware and software, making them versatile for different users. Server operating systems are designed to manage network resources and provide services to other computers. Examples include Windows Server and various Linux distributions. These OSs are optimized for stability, security, and handling multiple requests at once. Embedded operating systems are used in specialized devices like smart appliances, cars, and industrial machines. These OSs are lightweight and designed to perform specific functions reliably, often with limited hardware resources. Cloud operating systems manage resources in cloud computing environments. They allow users to access applications and data over the internet, providing flexibility and scalability. Cloud OSs are essential for modern web services and online platforms. Open-source operating systems like Linux are developed collaboratively and are free to use and modify. This encourages innovation and allows users to customize the OS to their needs. Open-source OSs are popular in education, research, and business. Proprietary operating systems are developed and sold by companies. Examples include Microsoft Windows and macOS. These OSs often come with dedicated support and regular updates, but users must purchase licenses to use them. Regular updates are important for keeping operating systems secure and efficient. Updates can fix bugs, patch security holes, and add new features. Staying up to date ensures your device runs smoothly and is protected from threats. Many operating systems allow users to customize settings, themes, and features. This personalization helps users create an environment that suits their preferences and workflow. Customization can range from changing wallpapers to installing new software tools. A key job of any operating system is managing resources like memory, processing power, and storage. The OS allocates these resources to different applications and users, ensuring that everything runs efficiently and without conflicts. Operating systems often include networking features, allowing devices to connect and share information. Whether it's accessing the internet or sharing files on a local network, the OS manages connections and keeps data flowing smoothly. Storage management is another critical function of operating systems. The OS organizes files, manages folders, and ensures that data is saved and retrieved efficiently. Good storage management helps prevent data loss and keeps your device organized. The operating system acts as a translator between hardware and software. It tells your computer how to use its components like the processor, memory, and input devices. This coordination is essential for smooth operation and performance. Operating systems are designed to make computers accessible to users of all skill levels. Features like user accounts, accessibility options, and help tools ensure that everyone can use technology effectively and comfortably. The future of operating systems is exciting with new developments in artificial intelligence, cloud computing, and security. As technology evolves, OSs will continue to adapt, offering even more features and better performance for users everywhere. To recap, we've explored the four main types of operating systems: batch, time sharing, distributed, and real-time. Each type has its own strengths and is suited to different tasks and environments. Understanding these differences helps us appreciate the role OSs play in our digital world. In our next lesson, we'll move on to computer hardware and its various types. Understanding both software and hardware is key to mastering computer basics. Stay tuned for more insights as we continue our journey through the world of technology. Thank you for joining us on Day 4 of Computer Basics. We hope you now have a clearer understanding of the different types of operating systems and their importance in everyday technology. Keep exploring, and we'll see you in the next lesson.